Hello everyone. Now we are going to learn something about self energy. Okay, let us see. So if we talk about self energy, then we can say that when we charge a sphere, let this is the sphere and it is conducting sphere. It is conducting sphere, and its radius is capital R, and we have given some charge to it, and that charge is let capital Q. Okay, so in that case the self energy of this sphere, that will be kq square upon 2r. It means we can say it will be 0.5 kq square upon kq square upon r. Okay, so actually it is the work done by the external forces to assemble this charge on the surface of that conducting sphere. Okay, that is known as u self or self energy. Okay, and we can derive it also. How? Let us see. If we say that at any moment t, the charge on this sphere is small q, which is the variable charge. Okay, and if we are shifting some charge from infinite, and that charge is let dq. Okay, then as we know that if we want to find out the work done to shift this charge from infinite to the surface of this sphere, then that work done, that will be dw, and that will be potential into dq. Okay, and now if we integrate it, then we will get that total work done. It means we will get total self energy of this sphere. So let us see total work done, that will come. Okay, and we as we know that at this point or near to the surface, v is k q upon radius is r here, r, and here it is dq. And now we will charges from 0 to capital Q. Work done is from 0 to w. Okay, thus we will get w 0 to w here, and k will come out, r that will be here. Here will be q square upon 2, that is the integration of this q with respect to q here, 0 to q. Thus we got w, that is kq square upon 2r. So that is the work done to shift total capital Q charge from infinite to the surface of this sphere. Okay, and that is known as the self energy. So we can say u self, that is kq square upon 2r, and it is 0.5 kq square upon r. Okay, that is u self. But now if we talk about the self energy of non-conducting uniformly charged sphere, then let us see how we can get it. So if we are giving charge a non-conducting sphere, then as we know that that charge will remain in the volume of that sphere. Okay, so let this charge is capital Q, radius is capital R here. Okay, so now we are going to find out the work done to shift this entire charge from infinite to the volume of this sphere. Okay, and this work done or this energy, that we can get from one more method. What is that? As we know that energy density per unit volume, that is half epsilon naught E square. Okay, you know that. Now if we want to find out the total energy inside that sphere, that we can get half epsilon naught, and E at a point which is inside this sphere, at this point value of electric field, that will be k q upon r cube into r. Okay, and if we square it, okay, and dv is the volume of that small element here. So we can say that if we take, okay, I think we should change the color here. If we take element, okay, so what will be the energy in this volume, that is du. Okay, and if we talk about the volume of this part, then as we know that will be dV, that will be the 4 pi r square, which is the surface area of this shell, okay, and let thickness is dr here, okay, so into dr, that will be dV. Or you can solve like that also. V is 4 by 3 pi r cube, and if we differentiate it with respect to r, then it will be 4 by 3, and pi it will be 3r square, 3 and 3 cancelled out, so dV that will be 4 pi r square into dr, okay. Thus we got dV. So if we put value of dV, then from here we can say that du, that will be half epsilon naught, here will be k square q square upon r raised to 6, and here will be r square, and dV that is 4 pi r square into dr, okay. And now if we integrate it, and if we take limit from 0 to capital R, okay, that will give us the energy inside that sphere. So 0 to R, so that will be U inside the sphere, okay. So if we solve it, we will get U inside the sphere, which is the energy inside that sphere, okay. So from here we got, we can say that I can take half common here, and here it is R raised to 6, and here it is 4 pi epsilon naught, 4 pi epsilon naught, and here it is k square, so I can write it as k and upon 4 pi epsilon naught, okay, that is k square, k into k, value of k is 1 upon 4 pi epsilon naught, and 1 k I put it as it is, and here it is capital Q square, correct, and 4 pi I have taken here, and that will be r raised to 4 dr, integrating it from 0 to r. So now from here we can say that 4 pi epsilon naught is cancelled out, and u in that will be k q square upon 2 r raised to 6, integrating r raised to 4, okay, so that will be r raised to 5 upon 5, limit from 0 to r. Thus we got u inside, that will be k q square upon 2 r raised to 6, and here it is r raised to 5 and 0 raised to 5 divided by 5, okay. So thus we got u in, it will be, and here if we solve it, that will be k q square upon 5 to the 10, r raised to 6, here will be r raised to 5, okay. So r raised to 5 and this power cancelled out, so u in that is k q square upon 10r, or we can write it as 0.1, okay, and k q square upon r, okay. So that is u in. So inside this sphere, the energy u in that is 0.1 kq square upon r, and outside it there will be energy. Why? Because there is electric field, and here also electric field. So where there is electric field, there will be the electrical energy also, okay. And outside energy u e out, that we have already got. And what was that? Here we can see that the energy that was outside the sphere, and its value that we got, that was 0.5 kq square upon r, okay. So u out that was 0.5 kq square upon r. So we can say that u total for uniformly charged non-conducting sphere of radius r, that will be 0.1, 0.5. So we will add them, we will get 0.6 kq square upon r, okay. So that is u total, or we can write it as 3 upon, we can write like that also, 3 upon 5 kq square upon r. But I will suggest you that you should learn it in this form, 0.6 kq square upon r, okay. Inside was 0.1 kq square upon r, outside it 0.5 kq square upon r. So in this form you should learn the data, okay, because in this way we can easily learn it, and we can say that what will be the inside energy, what will be the outside energy, and what will be the total energy, okay. So that's the concept here, okay. And we can write this 0.5 like kq square upon 2r, but I would say that you should learn it in this form, which is 0.5 kq square upon r, okay. So that was the total concept of self energy of sphere for conducting also, and for non-conducting uniformly charged sphere also, okay. So I hope you got it, Thank you very much.